Okay, so in this lecture, we're going to talk about defining variables, functions, and where these artifacts live, otherwise known as scope. Now, it's fairly straightforward how you define a variable. Variable definitions should always start with the keyword var. Now, notice that no types are declared in JavaScript. And the reason that is because JavaScript is called a dynamically typed language. Now, what that means is that the JavaScript engine figures out the type of a particular variable at runtime. And it also means that the same variable can hold different types during the life of the execution of the program. So a variable can start out to be a string, then change to a number, then change to an object, and so on. And all of that is perfectly legal. So that's as far as variable definitions. Now, the way you define a function is by using the keyword function followed by function name and followed by parentheses and then curly braces. Now, in JavaScript, when you define a function name, it's very, very similar to defining a variable whose value is a function. So, for example, you could define a function in JavaScript by either using the keyword function followed by the function name, or you could create a variable and set it equal to a function. Now, when you do it the second way, no name is defined after the function keyword. However, either syntax lets you refer to this function as a. Now, notice that the value of the function is assigned to a, not the returned result of the execution of that function. So after either of these definitions, you could now invoke, otherwise known as execute, function by referring to it by its name a. Now, once you define the function, either you define the function the first way that we talked about or the second way where you store the function inside of a variable, the way you invoke a function is by taking the name or the reference to that function and putting the parentheses afterwards. So that is called a function execution or function invocation. Now, the word execute and invoke are synonyms, so you could really use either one. But in programming literature, it's very often that the execution of a function is referred to as invocation of that function. Now, you can also define arguments to be passed to the JavaScript function. Now, the defined arguments are defined without the keyword var. In fact, if you place the keyword var in the function argument definition, that will be a syntax error. If you want your function to return some value, you use the return keyword followed by whatever value it is that you want to return. If the return keyword is not followed by a value, what you're signaling to the JavaScript engine is that it should terminate the function and exit out of it without returning anything. Now, the way you pass the arguments to the JavaScript function is also kind of unique. So in the first line of this example here, we have the function compare that we saw in the previous slide, and it's defined here with arguments x and y. In the second line, we're executing or invoking function compare and passing to it two arguments, 4 and 5. Now, the result of the execution of that function is then stored in the variable a. On the third line, you notice that we're still executing the compare function, but we're not storing the result anywhere. That is perfectly legal. And it's also legal, since JavaScript is a dynamically typed language, to pass a as a second argument as a string as opposed to a number. Now, that may not make sense as far as the logic of the function is concerned, but it's certainly perfectly legal syntax. Now, the last line demonstrates yet another rule about JavaScript functions. All arguments defined in a JavaScript function are optional. You can call that same compare function without any arguments at all, and it will all be perfectly legal. Again, it may not make sense as far as the business logic of the execution of the compare function, but the syntax and the invocation of this function is perfectly legal. Now, each function or variable lives within a particular scope. In JavaScript, there's really two scopes: global scope and function, or otherwise known as lexical scope. Now, lexical here means that it depends on where something is physically defined. Like, for example, a variable that's defined within a function is physically defined within that function. There's no block scope in JavaScript. In other languages, curly braces themselves signify a new scope. In JavaScript, functions signify a new scope. That's all you really need to know about functions for now, and we're going to talk about functions in much more detail in a later lecture. Now, variables and functions defined in a global scope are available everywhere, meaning any other functions that are defined in a global scope and so on can get access to these globally defined functions and variables. As far as function and lexical scope, variables and functions defined here are available only within this function. And you heard it right. You could define functions within other functions. And those newly defined functions have a way to get at its outer function variables and functions. Which leads us to the next topic, the scope chain. Now, in order to understand how scope chain works in JavaScript, you have to understand how JavaScript engine executes things. Everything in JavaScript is executed in an execution context. Now, a function invocation creates a new execution context within which that function is executed. Now, each execution context has the following. Number one, it has its own variable environment. This is where it stores its newly defined functions and variables. It also gets this special this object, which we're going to talk about at a later lecture. And what's most important for our discussion right now, it gets a reference to its outer environment, meaning the execution environment within which this particular function is defined. Now, global scope does not have an outer environment simply because it's the most outer there is. So here's how scope chain works. Referenced, notice referenced, not defined variable, will be searched for in its current scope first. If not found, the outer reference will be searched. If not found there, the outer reference's outer reference will be searched, and etc. and so on. Now, this will keep going until the global scope. If not found in global scope, the variable is going to be undefined. Now, we'll discuss the special value undefined when we speak about JavaScript built-in types. But for now, just know that the variable undefined means it's just not found. Now, in order to understand this scope chain a little bit better, let's take a look at the following visualization. Suppose you executed a couple of lines of code inside the global scope. The first line defines variable x and assigns a value of 2 to the variable x. And the second line executes function a. Now, function a itself is defined in global scope, and it has its own variable x that is set to 5. Now, then, within function a, you call function b. Function b is also defined in the global scope, and all it does is just print out to the console the value of x. Now, what will be printed out to the console? Will it be x equals 5 because b is invoked inside function a? Or will it be x equals 2 from the global scope? And the answer is that the result that will be printed will be x equals 2 from the global scope. Now, why is that? Well, if you remember what we just said, the reason is pretty simple. Even though b is called within a, and a has its own x, what actually matters as far as resolving where x is coming from is its outer reference, and b is defined within the global scope. Therefore, the outer reference of function b is the global scope, not function a. What this means is that it does not matter where a particular function is executed. What matters as far as resolving scope of a variable is concerned is where that function is physically defined. Function b is physically defined inside the global scope. Therefore, a reference of x inside function b is going to look inside function b first. If it doesn't find it, it's going to use its outer reference to look for it there. And its outer reference is the global scope. Let's jump to the code editor and see an example of this.